Hello guys, good morning. You are welcome to my YouTube channel, the Explicit Tutorials. And as you all know, my name is Tutor Joseph. This morning I shall be taking on CHEM 1 to 4, a topic called what? Alkanols. Let us get started. You know, alkanols, they have their functional group as what? OH, that is their hydroxyl group is their what? Functional group. And these alkanols, they have different states of matter. Lower members are liquid and higher members are what? Solids, ranging from what? Carbon 12 and above. Take note of that. Now we have different sources of what? Alkanols. Now alkanols, the OH can be gotten from carbohydrates, cholesterol, and even what? Derivative of amines. There are different sources these alkanols are what? Gotten. So we now have this variability in the form of liquid, solid is as a result of what? The presence of hydrogen bond present in it. All right, so this are what you can just read on your own. The major things are the reactions that occur during what? The reaction that occur during what? The preparation of these idiots alkanols. Now I've given the sources, variability in state of matter as a result of what? Hydrogen bond. Now please, the isomeric expression of these alcohols is in the form of 1, 2, 3. That is primary alcohol, secondary alcohol, and tertiary alcohol. Take note of that. It is very, very important. And secondly, alcohols and water are what? Is eutropic mixture. Alkanol, that is alkanol, alcohol and what? Water are what? Is eutropic mixture. If I don't call it isotropic mixture, I'll call it what? Constant boiling mixture. In this, you have about 95.5% alcohol and you have 4.4% what? Water. So combination of these two idiots is called what? Isotropic mixture, and also called constant boiling mixture. They are separated from each other through distillation, and they both boil at a common temperature of 78.3 degrees Celsius. All right, they both boil at a temperature of 78.3 degrees Celsius. That is for that. And secondly, what is left? Okay, now methanol, preparation of methanol and what? Okay, let me give you the test first. How do we test for alkanols? Alkanols are tested using what? Lucas reagents. Alkanols are tested using what? Lucas reagent. Lucas reagent is a combination of concentrated hydrochloric acid and what? Zinc chloride. Lucas reagent is used to test for alkanols. It's a combination of HCl and zinc chloride. Now, reacting Lucas reagent with tetra alcohol, it reacts very fast. All right, it reacts very fast and produces what? Cloud. Then secondary alcohol react within 5 minutes. The primary alcohol partially reacts or does not even react at all. All right, so this is how to test for what? Alkanols. Now we have different types of alkanols based on the number of OH present in the molecule. An alkanol having just one OH is called what? A monohydric alcohol. An alcohol having just one OH is called what? A monohydric alcohol. A good example is what? Ethanol. Alright, then an alcohol having two OH present is called what? A dihydric what? Alcohol. A good example is what? A glycol. You know, glycol is otherwise called what? Ethyl 1,2-diol. Ethyl 1,2-diol. An example of a trihydric alcohol is glycerol. No, glycerol is otherwise called what? Propan 1,2,3-triol, which is produced during what? Saponification reaction. You now have what? A polyhydric alcohol. Polyhydric alcohol is an alcohol having 4 OH molecule present in it, and a good example is what? Glucose. That's a type of what? A monosaccharide. So these are the types of alcohol based on the number of OH present in their molecule. You now have types of alcohols based on the position of position of what? OH attached to the carbon atom. Primary, secondary, or tertiary. So take note of that. It is very, very important. Now, how are methanol and ethanol produced? Let me quickly explain methanol. Methanol is a poisonous gas. It's highly poisonous and it can lead to blindness when consumed. It is prepared when hydrogen molecule react with carbon 2 oxide in the presence of what? A chromium 3 oxide or zinc oxide. Now you now have CH3OH. Alright, so you can see now that a methanol has been produced. It is poisonous, alright, and it should not be consumed because it can lead to blindness, total blindness to be specific. Now, this methanol is also produced through destructive distillation of wood. Destructive distillation of wood. Now, during this process, the lignin present in wood is burned in the absence of air to produce charcoal and a volatile entity called heavy oil. Now, during this process, charcoal is produced and a type of acid is produced called a pyroligneous acid. And this pyroligneous acid comprises, I said heavy oil is also produced, don't forget. This pyroligneous acid comprises acetic acid, acetone, and methanol, and other contaminants. Please take note, methanol is used as fuel in automobiles. It's also used as cleaning agent in cleaning industry. It's also used as antifreeze. So take note of that. So this is another way of the industrial preparation of alcohol, and this is the preparation of alcohol, partial digestion of excuse my stomach. So this one is the industrial preparation of alcohol, and this is another way of producing a methanol. Please, it's methanol, actually methanol. Now that is for that. Please take note of it. Now, how do we produce ethanol? How do we prepare ethanol? Let's use the word prepare, not produce, please. How do we prepare ethanol? Ethanol is prepared when you have 10O5 then plus water molecule. Now this reaction occurs in the presence of a diastase. This diastase, this entity now have C12, then 2 plus 10 is 20 plus 2, H22, 2 plus 5 is 10 plus 1, O11. Alright, this is a maltose. Now this maltose is converted to glucose by an enzyme called maltase. Don't forget, diastase is produced by yeast. Now bring it over, it becomes C12H22O11. Now, in the presence of an enzyme called maltase, this maltose is converted to glucose, C6H12O6. Alright, so this glucose is brought here, C6H12O6, in the presence of an enzyme called zymase. You now finally have an ethanol and carbon 4 oxide. Right, so please, this is the ethanol we've been trying to produce. Finally, it has produced. Take note of that. So, how do we prepare other alkanols? Preparation of other alcohols. Let us get started. I believe this is understood. Diastase and zymase are produced by yeast. The enzyme that converts maltose to glucose is maltase. So don't forget, enzyme that converts glucose to ethanol is what? Zymase. This is what? A fermentation reaction. Good. Fermentation reaction. So how are other alcohols produced? Other alcohols are produced by the hydration of what? Anethane. I have that is water is added, remember. Now in the presence of what? H2SO4. Now you know this H2SO4 can be split into H plus and what? OH minus. Hydrogen ion and what? Hydroxyl ion. Now bring it out, it becomes H becomes, you now have CH. Okay, let me write it out. H OH. Alright, how many carbon atoms? We have 2, 6. So the OH will come here and the H will come here, such that this double bond is what? Overcome. We'll not be having a double bond in it. So you can see that we have successfully prepared what? An alcohol. This is number 1. Alcohol is also produced from ethyl halide. It's also produced from ethyl halide. Now this halide could be a salt, it could be any element in the group 7. It could be chlorine, bromine, fluorine, astatine, and what? Iodine. Ethyl is denoted using what? Arrow. So the halide, I can use X. Alright, then plus. Now when an ethyl halide is reacted with a base or an alkali, it will produce the corresponding salt and alcohol. This, look at this arrow becomes arrow OH plus what? Sodium halide. This same halide can react with zinc hydroxide. Okay, silver hydroxide. You have arrow OH and what? Silver halide. So that is how it is. Number 3. Alcohol is also produced when esters are reduced. I have arrow COO arrow in the presence of what? Sodium in what? Ethanol. Sodium in ethanol is used to reduce ester to what? Okay, you have 2. I can do it as arrow to CO CH2OH. Alright, so we have successfully produced what? An alkanol. This reaction, the process by sodium in alcohol is used to reduce ester to produce an alcohol, is called what? A Bouvier-Blanc method. Alright, so please take note of that. I believe these ones are understood. This number 3. Number 4, it can also be produced from alcohols are also produced from saponification reaction. You know, a saponification reaction is a reaction. Saponification reaction is a reaction between an acid and what? An alkali. It is a reaction between an acid and what? An alkali to produce salts and what? Water. Look at this, sodium is coming over, becomes ROCOONA plus this H plus becomes what? Water. Alright, so you now have what? This is sodium ethanoate. Sodium ethanoate. That is ester salt, then plus what? Water molecule. Alright, so from saponification reaction we can produce what? Okay, sorry. It is reaction between an ester and what? A base. Please. It just escapes me. Now, under acidic condition, ester is under acidic condition. That is under H plus. You have formation of acid and what? OH. Alright, you know water can be split into H plus and what? OH minus. Now this H is coming here, becomes ROCOOH. Then this arrow makes it now have what? Alcohol. It's a chemical reaction. It is also produced from carbonyl compounds. Carbonyl compounds are aldehydes, ketones, acid chloride, and what? Acid anhydride. So please look at, let's try it. All right, so I have ROCOCl. Okay, let me put it this way. Alcohol are produced from the catalytic hydrogenation of what? Carbonyl compound. Catalytic. That is in the presence of catalyst. All right. And use H2SO4. Now, hydrogenation is the addition of what? Hydrogen atom. So in doing this, please take note. When hydrogen atom reacts with acid chloride, it produces an alcohol and what? Hydrofluoric acid. I have ROCH2OH plus what? Hydrochloric acid. Alright? But when it reacts with acid anhydride, it will produce an alcohol and what? Water. An alcohol and what? Water. Alcohol and what? Water. But I have, okay, sorry. This 2 is written outside. You have 2 arrows. I can put 2 here. So let's balance oxygen. 3 oxygen. 2 oxygen. That's 3. The hydrogen atom. You have 8, then we'll put 4 here to balance it. So we have successfully produced what? Alcohol from what? Carbonyl compound. That is, now I have ketone, ROCO plus what? H. Don't forget. Now I'll have, how many arrow do I have here? 2, right? I'll do it as arrow, then CHOH. And now canal as what? Produced. It has been produced. So I have 2 arrow, 2H, 1O. So it is what? Balanced. It is balanced. Is there another one again? Is there another one? Okay. It is also produced from Grignard reagents. You know Grignard reagents. Okay, let me take it up, please. Grignard reagent is an organo magnesium halide. Organo magnesium what? Halide. Now this halide I said could be chlorine, bromine, what, or what? Iodine, as the case may be. Now, primary alcohol is produced when this Grignard reagent reacts with what? A methanol. Another word for methanol, please. The trivial name of methanol is what? Formaldehyde. And this is the chemical formula HCHO. This methanol, otherwise called formaldehyde. Take note of that. So let's take it. Grignard reagent reacts. Let me use bromine. React with what? Formaldehyde. I have H. Alright, now this H will come here, becomes, I have H, I have O, combined with this, magnesium bromide, then I have what? H. I have arrow, this, I know I think that this arrow will come here, you now have what? Arrow. Now please, when When a Grignard reagent reacts with carbonyl compounds, ketones, aldehyde, acid chloride, and acid anhydride, it will produce what? An alkoxide. So this compound is written as, I have arrow, CH2O, then MgBr. This is called magnesium alkoxide. Alright, magnesium alkoxide. Alkoxide is produced when Grignard reagent react with carbonyl compound. I'm still saying it. But we have not produced alkanol now. Now, in the presence of what? Hydrozonium ion, H plus. Finally, we can now produce, we have arrow, we have H, we have H, we have, okay, OH and what? Arrow. We then have arrow, CH2OH. Alright, so we have successfully produced what? A type of alkanol called what? Alkanol also called what? Alcohols. Alright, so please, this is how it is. Then secondary alcohol is produced when Grignard reagent with what? When it reacts with aldehyde. Sometimes they may not give you reaction. They may ask you, which of the, okay, the reaction of Grignard reagent with methanol will produce which of these? Please, it is what? Primary alcohol. But the reaction of Grignard reagent with aldehyde will produce what? A secondary alcohol. The reaction of Grignard reagent with ketone produces what? Tertiary alcohol. So we have done the preparation of alcohols. Now the next one is what? The reaction of alcohols. What kind of reactions do they undergo? Excuse me, let me check if it's recording. Okay, thank God. Now the reaction that alkanols undergo. One, they undergo an esterification reaction. Now this is a reaction between an acid and alkanol. That is, it is a reaction between alkanoic acid or carboxylic acid and alkanol to produce ester and water only. This arrow is coming over, it becomes arrow COO arrow, then plus water. Don't forget the hydrating agent is what? The catalyst uses H2SO4. Alright. Then secondly, formation of urethran. Formation of what? Urethran. Alright. Alcohol will react with phenyl iso. Alcohol will react with phenyl isocyanate to form what? Urethran. This is, you have arrow N, double bond C, double bond O, plus what? This alcohol, right? You have arrow NH, COO arrow. This is what? An urethran. Alright, so formation of urethran. Sometimes Uniben is fond of doing this. They might just put Y or X. They'll say from the above reaction, Y represent which of these? It is what? Urethran. Okay. Number 3. Alcohols can also undergo what? Dehydration reaction. Dehydration what? Dehydration reaction. In this case, you have C5OH in the presence of H2SO4. Now I would move one H from here. I'm left with what? C2H4 plus what? Water. Dehydration, removal of water. This is the water has been removed. And the agent used here is what? H2SO4. Take note of that. Then, please, in the dehydration of excess alcohol, it will produce a diethyl ether. This is C2. You have C2H5, C2H5O, C2H5. So this is 2-ethyl is called what? Diethyl. Then ether. Now this is the ether functional group, alright? So which means that the reaction of the dehydration of excess ethanol produces what? A diethyl ether or diethyl alkanol or alkoxide. So please take note of that. It is very important. Then lastly, they can also undergo oxidation reaction. They can also undergo oxidation reaction. Oxidation reaction. Number 5. Okay, number 4. Yeah, can also undergo what? Oxidation reaction. I have H, OH, H. During this reaction, potassium permanganate and potassium heptaoxodichromate 7 is what used as the oxidizing agent. Now, let us get started. During this process, OH is removed. Alright, we now have CH3, then CHO. So which means the oxidation of primary alcohol, the partial oxidation of primary alcohol produces what? An aldehyde. You can see this is what the aldehyde functional group. But the complete oxidation of primary alcohol produces what? A carboxylic acid. Now, plus, okay, I want to add oxygen. If I should add oxygen to this molecule, it becomes what? CH3COOH. Alright, this compound is called what? An ethanoic acid or acetic acid or carboxylic acid, as the case. You can see this is the carboxylic functional group. Alright, so that is for that. The oxidation of primary alcohol produces what? Aldehyde and what? Carboxylic acid. Please, the color change. Potassium permanganate changes from potassium permanganate changes from purple to colorless entity. Alright, it is purple in color, but potassium heptaoxodichromate 7 changes from orange to what? Green. Take note of that too. These oxidizing agents will change. This one will change from orange to green. This one will change from purple to what? Colorless. Take note of that. Please, I said when I was discussing or telling us the ways of producing alcohol, I told you that esters are reduced. When they are reduced, now what? Alcohol. Please, there's something you must note. Okay, another reaction of alcohol is alcohol also react with acid chloride and acid anhydride. Good, thank you Jesus. Now, you know acid chloride is RCOCl plus what? O. If acid chloride, I don't know if have I given us this one? I don't think so. So if an alcohol should react with acid chloride, this is acid chloride. This is the chemical formula. It will produce an alcohol and what? Hydrochloric acid. That is ROCH2OH plus what? Hydrochloric acid. Alright? Hydrochloric acid. But if I don't know if I've given us before, but let me take it in case we were not given before. Now, plus ROH. When an alkanol reacts with an acid anhydride, this is acid anhydride. All right, it will produce a carboxylic acid and what? It will produce an ester and what? A carboxylic acid. So please take note of that. It is very, very important. So at this point, we call it a day. Don't forget, oxidation of primary alcohol produces aldehyde and carboxylic acid. The oxidation of secondary alcohol produces what? A ketone. Produces what? A ketone. The tertiary alcohol cannot be what? Easily oxidized. Primary aldehyde carboxylic, secondary ketone. Take note of that. So at this point, we call it a day. Thanks for watching and do have a wonderful day. Please endeavor to subscribe. In our next class, we are going to be discussing phenols. How are phenols produced? You know that phenols are actually compound produced when when hydroxyl group is combined to a benzene ring. When you have one, it is what? Just phenol. When you have two, it is 1,2-dibenzene or 1,2-phenol. Then when you have three, it is 1,2,3-trihydroxyl benzene. So please take note of that. It is very important. So at this point, we call it a day. In our next class, I shall be treating phenols. Thanks for watching and do subscribe.